Okay, let's add some more formulas in here, and I just kind of want to prove one of them at least. So sine of 2x, well, that's the same as sine of x plus x. Well, let's remember we had that formula with the addition sine of one angle plus another. That gives me the sine of the first times the cosine of the second plus cosine of the first times sine of the second. Well, look at that. That's really sine x cosine x plus sine x cosine x, which ends up giving me 2 sine x cosine x. Now, there's whole definitions, whole reasons why these are. If you want to see the proof, that's fine. But we can find all of these given some information. Now, we haven't done one of these in a while. This is coming away from the unit circle, and instead we are given some information. So we are given that cosine of some angle is negative 2 over 3, and t is in quadrant 2. Okay, so quadrant 2. Let's think about that. Quadrant 2, that would be over here. All right, and so we're not in the unit circle anymore. So this is x and this is r. Okay, so x is negative 2, and so we're in quadrant 2, so we're here. X is negative 2, r is 3. I need to find the y value there. So x squared plus y squared equals r squared. So negative 2 squared plus y squared equals r squared. 4 plus y squared equals 9. Y squared equals 9 divided by 9 minus 4, which is 5. Y equals the square root of 5. Now, you could have also done cosine squared plus sine squared equals 1. And believe it or not, you would have ended up getting the same answer, because sine of that angle, so we have cosine of the angle, cosine is negative 2/3. Sine is going to be square root of 5 over 3, y over r. And tangent is going to be sine divided by cosine, or opposite over adjacent. So that's going to be square root of 5 over negative 2. And that's all I need to be able to fill in these formulas. So sine of 2t is going to be 2 times the sine of t cosine t. So sine of t is square root of 5 over 3. Cosine was negative 2 over 3. So that gives me negative 4 square root of 5 over 9. Cosine of twice the angle is cosine squared, which means I'm going to take cosine of t and then square it, minus sine of t and square it. So cosine was negative 2 over 3. Sine was square root of 5 over 3. So that's going to be 4 over 9 minus 5 over 9. That's negative 1 over 9. Tangent of twice the angle. It's going to be 2 times the tangent over 1 minus tangent squared. Okay, so in the top, the 2's would cancel, and I'm left with negative square root of 5. in the bottom, I'm going to have 1 minus. When I square that, I'm going to get 5 over 4. So 4 fourths minus 5 fourths is negative 1 fourth. So that's going to be negative square root of 5 times negative 4 over 1. That's 4 square root of 5. Now the next one asks us to verify. I like those a lot better. Verify that that equals that. So, okay, so let's see. How can I verify that sine of 2x really equals what we have on the right side? Let's see. So sine of 2x, I can rewrite that as 2 sine x cosine x 1 minus cosine squared x minus sine squared x. And we're trying to get that to equal cosine over sine. If I distribute that negative, I get 1 minus cosine squared plus sine squared. Now be really careful here. This is not cosine squared plus sine squared, because this is a negative cosine squared. But 1 minus cosine squared is sine squared. So I have sine squared plus sine squared. That's 2 sine squareds. Which the 2's would cancel, sine would cancel out with one of these, and I'm left with cosine over sine. That's pretty nifty. All right, the other ones, and this is more of what I have on the homework. I think I have one with the double angles, but I think these are more fun. These are product to sums and sums to products. So I just have to find the ones that match. So I have sine of something plus sine of something. Here it is. Sine of something plus sine of something. So 5x and 3x. So I'm going to do 2 sine of their average, so 5x plus 3x divided by 2. And then cosine of their difference divided by 2. So 2 sine of, that'd be 8x divided by 2. And then cosine of 2x divided by 2, which is just x. Cosine minus cosine, that's this bottom one. Negative 2 sine of 6x plus 5x divided by 2. And then sine of 6x minus 5x divided by 2. So this is 11x over 2 and 1x over 2. Ooh, sine times sine. Oh, that goes over here. Sine times sine. So that means 1/2 of cosine of first minus the second minus cosine of first plus the second. Okay, so that's 1/2 of cosine of 2x minus cosine of 8x. Now this next one, I think it's easier to rewrite this because multiplication, you can write it in either order, but I like to have the bigger one front. And cosine, cosine, there it is. It's going to be 1/2 cosine of u plus v, so 4x plus x, plus cosine of their difference, done. cosine sine. Oh, I'm going to rewrite this as sine first because I like the bigger angle in the front. Sine, cosine. Look up, there it is at the top. It says 1/2 sine of them added together plus sine of their difference. Now this next one gets a little interesting. I have sine plus sine in the bottom. And in the top I just have sine of 8x. So let's see what happens. I'm going to use that formula from the top of the page on the denominator. It says do 2 times sine of 7x plus x divided by 2, and then times cosine of 7x minus x divided by 2. Oh no, that's not going to help me with this top one. Wait. What if I think about 8x as sine of 2 times 4x? Then it's a double angle. And the double angle formula said if I have sine of 2 theta, that's going to be 2 sine theta cosine theta. So that's going to be 2 sine of 4x cosine of 4x. See if that helps. In the bottom I have 2 sine of 4x cosine of 6 divided by 2, 3x. Ooh. Now be careful, the cosines do not cancel, the x's do not cancel. They have to match perfectly. Try the last one. I'm not going to talk through it. I'm just going to write my answer. So I applied the formulas. Now we're simplifying. 4x divided by 2, 2x divided by 2, wait, that's just tangent. How beautiful it is.